Good afternoon, everyone. Welcome to the online class sessions conducted by ASAP, Additional Skill Acquisition Program, Department of Higher Education, Government of Kerala. Today, as you all know, we are going to have a class for the 6th semester BArch students on the subject Building Materials and Construction Techniques. To handle the session today, we have with us Professor Subhash Verma, Associate Professor, 𝐷𝐾𝐫 College, Kollam. Dr. Subhash acquired his B.Arch degree from 𝐷𝐾𝐫 College of Engineering, Kollam, and M.Tech from IIT Madras in Building Technology and Construction Management. He is registered with the Institute of Architects and Indian Green Building Council accredited professional as well. In addition to his teaching experience, which spans over 20 years, he has also had his own architectural consultancies also. Sir, it is a pleasure to have you here, handle a class for our students. Over to you, sir.
Thank you. Yeah, good afternoon and welcome to the session. I thank you all ASAP coordinators for inviting me for this session. So this session is basically a discussion on modular coordination. Modular coordination is associated with the construction industry. Modular coordination has developed recently, and it is basically a standardization of dimensions. So in the picture, you can see a Rubik cube, which is familiar to all. It is a very good example to explain what is modular coordination. So each phase, you can see 9 modules of homogeneous size. And similarly, the cube has 6 phases. So each module, each unit, you can call it a module, and the entire block, entire Rubik cube is made of such similar modules. So in similar way, this is also possible in the construction industry. So today, I'm going to discuss a few topics. First is introduction to modular coordination. Then what are the objectives of modular coordination? And then what is a basic module, its definition? Then what is meant by modular controlling dimensions? And what is a planning module? And what are the preferred multi-modules? So after the discussion, I'll be showing some examples to know how this concept can be applied in building construction. Before we go to that, we should just browse through the history of modular coordination. So basically, this modular coordination, the concept was evolved when the thought of prefabrication in construction came to exist. And this was first studied in Singapore in the early 1970s. And this was when the metrication was introduced. You know what is metrication? Metrication is a process of converting all your local or basic dimensions into metric units or the SI units. So when this metrication was introduced, the thought of modular coordination become important. So this concept was practically implemented by the Housing and Development Board in 1973 in the construction of a set of new generation flats. And in 1983, modular bricks and blocks were made. So the entire process of research and development was taken place in Singapore. So as I said earlier, modular coordination is a way of standardization, basically standardization of dimensions. So it is a process of organizing dimensions. It links both design and construction. And also it's a way of coordinating dimensions and spaces. And it can be applied either comprehensively or partly. So in any construction, you can apply this modular coordination concept either partly or to the whole building. So we can say that modular coordination, modular coordination can be defined as a dimensional coordinate system which comprises of the basic module, multi-modules, sub-modules, and a modular reference system. So there is a basic module associated with modular coordinates. Then there is a multi-module which is the multiple of the basic module, and sub-modules which are the parts or the subdivision of the basic module. So, and there should be a modular reference system, which is a coordinate system, which gives indications about where to place the modular member. So it is also a concept of coordination of dimension and space, in which building components and dimensions are dimensioned and positioned in a term of basic unit or module. So again, the concept is associated with building components. So this will, the modular coordination system will assign a dimension as well as a position to the basic module. Yeah, this is a very good example, and I think most of you are familiar with the 𝐶𝐻 It's a very good example to understand what is modular coordination. So all these 𝐏𝐫 is comprised of three basic modules. One is the post module, then you have the slabs, and there is a coping. So this can be made in the factory and assembled at site, and similar prototypes can be used anywhere. Again, the modular switch, the switch itself named as modular switch. All these components are standardized. You can just install it anywhere. Yeah, this is something, it's a kind of a toy known as building block. This is also modular. You can see smaller modules as well as larger modules. You can assemble them together and build anything. So where we can apply this modular coordination? So we can apply this modular coordination to conventional constructions or to buildings which are partly prefabricated, or buildings which are completely prefabricated, or to the buildings which are industrial, which are meant for industries or factories. So what is the basis of modular coordination? So we'll try to see what is the basis. There are three important aspects. One is the first basic aspect is the use of modules. So the modular coordination, as I said earlier, is associated with the use of modules. We have three types of modules, which is the basic module, multi-module, and the submodule. And then the modular coordination is a reference system. So this defines a coordinating space and zones for building elements and for the components. So with the help of this modular coordination system, building spaces and building components are dimensioned and assigned a particular location. And third aspect or third basis for the modular coordination is a certain rules. So these rules are for location of the building element. Usually we depend on the coordinate system, X, Y, Z coordinate system. Then sizing of the building components. Usually we depend on millimeter dimensions. Then preferred size of building components. Preferred size means that the building component should either fall to the module or a subdivided module or a multiple module, and then the coordinating dimension for buildings. And we should now observe how this modular coordination works in construction. So this modular coordination offers more standardized design solutions. You can construct prototypes in the factory and you can assemble it at site. It allows dimensional compatibility of elements. So all the dimensions has to be set to the modular size and it has to be compatible. And it's a coordination, it allows the coordination of dimension and position of elements, components, and space in the building. So all these aspects should fall into the modular coordinates. And it improves the balance between quality, time, cost in production and construction stages. That is a very important aspect. Because of modular coordination, one can go for mass production so that the quality, especially the dimensional precision and material quality, can be maintained, time and cost can be controlled. And what are the benefits of modular coordination? So we can say that there are 5 important benefits. One of the benefit of modular coordination is it improves the coordination between stakeholders. So every time you don't have to give instructions, because with a set of early given instructions, you can coordinate the entire building construction process, because everything is set to a pattern or a set of coordinated system. So it gives a better coordination between stakeholders. Then there is a reduction in time due to standardization. Then it encourages mass production and prefabrication. So since all the dimensions are fixed or early predetermined, you can make the components in the factory and you can go for prefabrication. And then there is a reduction in manufacturing and installation costs because all kind of overheads can be minimized. Then there is a reduction in material wastage, time and manpower. So the whole process can be run very systematically to ease the construction process and also to reduce the time and cost. And there are 6 objectives associated with modular coordination. So this modular coordination will help to improve the quality by standardization. So another objective is to encourage design standardization. Then to improve productivity by mass production, to reduce wastage, repeatability and control is the measure to reduce wastage. So modules, since the modules are of similar nature, repeated production can be done and quality control can be maintained to increase the speed and to reduce the time and cost. So there is an early planning. You can reduce the time as well as the cost of construction. And also this modular coordination has the objective to facilitate prefabrication or off-site production. So this off-site production is possible because all the modules are pre-designed. So you can construct the modules in the factory and transport the modules to the site, and you can assemble there with the help of a program. Then we'll discuss what is a basic module. So we have already discussed that the modular coordination is associated with the standardization of dimension. So you can say that a module is a dimension used as a basis for modular coordination. So there is a basic unit which you call it as a module. I'll give you some example from the traditional architecture of India. So we can see, when you observe that, we can see that the traditional architecture of India has applied the aspect of modular coordination very subtly. You can see, because I'll tell you the example of the design of Indian temples, where the dimension, the width of the prasada or the sanctum sanctorum becomes the basic module, and the entire complex is planned on the basis of the grid developed with this size as the basic module. And this basic module in traditional architecture is known as the dand. Similarly, in Indian iconography and Indian sculptures, the concept of module is used, and the name of the module used is called tala. So you can see that there is Ashtatala, Navatala, Dashatala, like that. So which means that 8 modules, 9 modules, and 10 modules, so on. So similarly, in the modular system accepted by the Indian International Standard Organization, the size of basic module, which is denoted as capital M, is 100 millimeter. So one module equal to 100 millimeter. So this is a grid which shows the size of a basic module. Well, this is a homogeneous grid where the horizontal as well as the vertical dimension is one module, and this is a basic, you can call it a basic modular grid. So apart from the basic module, we can have multi-modules, sub-modules, and something called a planning module. So multi-module is an agreed multiple of 100 mm. 100 mm is the standardized modular unit as per the International Standard Organization, ISO. So multi-module is denoted as small n and capital M. Then submodules, a module which is an agreed subdivision of 100 mm is a submodule. And finally, the planning module is a module chosen for planning a grid. So it is associated with the planning of grid. This is known as a planning module. Next slide, please. Yeah, this picture is a square multi-modular grid. So along the vertical direction, you have NM, NM as the multi-module. Along the horizontal direction also, you have the same NM as a multi-module. So the module is divided into 9 smaller units or the basic modules. Next slide, please. And this is again a multi-module, but of different size along the horizontal and vertical direction. Along the horizontal direction, it is N-M, and along the vertical direction, it is NM. So N is not equal to N dash. N dash is slightly bigger than N. And this is what is, the picture shows modular controlling dimensions. So you can have modular controlling dimensions in the horizontal direction as well as in the vertical direction. So when we talk about the more horizontal controlling dimensions, we have clear spaces between the pillars or the clear spaces between the wall elements is one horizontal controlling dimension. Then there are center line distances between the structural members or between the columns, another controlling dimension. So when it is a horizontal controlling dimension, you can have either clear dimensions as well as center to center distances as the horizontal controlling dimensions. Then the vertical controlling dimensions, we have clear heights or the thicknesses of various components. For example, the thickness of the floor is a vertical controlling dimension. The clear distance from the floor to the ceiling is another vertical controlling dimension. The sill level is another controlling dimension. The lintel level, similarly, another controlling dimension. So we can have either horizontal controlling dimensions as well as vertical controlling dimensions. And usually in a construction, in a design, we apply both. What are the various planning modules? What are the recommended modular dimensions? So this table explains the basic module is one module which is 100 mm. Then for a structural grid, we usually use 3M as the first preference. 1M can also be used as a second preference. For a horizontal multi-module, we use the 3M as the first preference and 1M as the second preference. For vertical multi-module, we use 1M as the first preference and 0.5M as the second preference. Those are usually multiples of 1M width, for the width and the height. Windows are usually multiples of 1M, both width and height. And usually we can use a submodular increment of 0.5 mm or 0.25 mm along with any of the above modules. And these are preferred multi-module. So in the first column, you can see that 3M, 6M, 9M, 12M, and 15M, which are the modular units. And vertically, you can see the grid sizes. So you can see that in the first column, the basic module, 3M module, it can be fit to more number of planning modules. So the 3M module can be fit to 3 by 3 planning module, 6 by 6 planning module, 9 by 9 planning module, 12, 15, like that. So there are more options for the smallest basic module, 3M module. It can fit to more number of planning modules. As the size becomes 6M, the basic module becomes 6M, then the number of planning grids to which it can be fit to is 6, 12, 18, 30, 36, 42, 48, and so on. And when the basic module become 9M, then again the suitable planning grids get reduced to 9, 18, 27, 36, like that. For 12 mm, again we have only 12, 24, 36, and 48. And for 15 mm basic module, we have only 15, 30, and 45. So from this table, we can infer that as the size of the basic module increases, it's the number of planning modules to which it can be fit reduces. So, we have already discussed the basic concepts in modular coordination, and then we'll discuss how it is practically applicable to all stakeholders in construction. So if we are going for a modular coordination, you can apply the modular coordination concept either to the entire structure or to certain parts of it. Anyway, if you are applying it either to the entire structure or to its components, there is a hierarchy which you have to follow in the planning of buildings. So the first priority should be given to the planning grid. You can apply the planning module to the planning grid. So after applying the planning module to the planning grid, you can advance the grid towards the elements of building, such as external envelope. You can apply on the external envelope. Then you can develop the grid, or you can enhance the grid to the components. For example, windows and doors can be designed according to the planning grid. Then finally, you can go for the last layer or the higher level of finishes and built-in equipments. So when you apply the planning grid to the entire 4 levels, the entire building, the whole building will be built according to the modular coordination system. Again, there are certain guidelines for practical application. So the first guideline is use the recommended modular dimension as much as possible. So if you can apply the modular dimension comprehensively, then it is good. Then if not possible, then you can standardize the building components as much as possible. Even if standardization is not possible, then you can choose a dimension that is proportional to, either can be a subdivision or a multiple to the modular dimension, and can apply it consistently. So either you can go for a comprehensive application of modular dimensions, or you can standardize a modular dimension, or standardize a building component and you can use it, or you can choose a dimension that is a proportionate value of the basic module and you can apply it consistently. So for practical application, you can use the following submodules. For example, if you are using the basic module of 3M, which is 300 m, the half of the basic module is 150 mm. The 1/3 of basic module is 100 mm. The 1/4 of basic module is 75 mm. And 1/6 of basic module is 50 mm. So these subdivisions can be used in the system. So, so what are the components where we can apply these the concept of modular coordination? So there are certain structural components like columns, beams, floor slabs, walls, stairs, and lift course. All these you can fit to the modular coordination dimensions. After that, you can think about applying it to architectural components such as cladding, partitions, doors, windows, and prefabricated toilets. Then you can extend the application to finishes like ceiling finishes or floor finishes. Yeah, this is an example where the modular coordination is applied. So this building is DBS Square, which is an office building in Singapore. And this building has been designed according to the modular coordination. So you can see a square grid of 90 m by 90 m has been used as a basic module. With that, as certain submodules are also used, like 57 m, 49 m, 41 m, like that. Yeah. And this is the same building, but shows how this modular coordination can be applied on the vertical facade. So basically, the vertical facade is composed of a 42 m module. The typical floor height is 42 m, but certain floors are used multi-modules like 60 m and 70 m. But generally, they have followed a 42 m module, which means that 42 m means 42 into 100, 4,200, which means that the height is 4.2 meters. So this is a detail of the facade. So you can see that the facade part plan, the facade part elevation, and the facade part section. So you can see the horizontal controlling dimensions such as window zone dimension, column zone dimension in the facade part plan, and the vertical controlling dimensions such as height of the window zone, height of the floor zone in the cross section. So in this building, both the horizontal controlling dimensions as well as vertical controlling dimensions has been implemented. This is another example, which is a housing project. You can see the typical flat unit. They have used different modules in the planning of the flat unit. The facade plan is also given on the left. They have used the modules of 32 m, 8 m, 32 m for the height and 8 m for the detail. And also below that, you can see the facade part plan where modules of 12 m, 8 m, 18 m are used. Yeah, this is the basic reference material for modular coordination. So in the beginning, I said that modular coordination, the research of and development of modular coordination was developed in Singapore. So this is a book published by, this is a literature published by the Building Construction Authority of Singapore. So for further reference, you can refer this. This is available online. So I have completed my discussion. Now it's open for question and answer session.
Okay, sir. One of the questions being asked is, what is the significance of vertical controlling component? That's what someone has asked. Significance of vertical controlling component.
Yeah. The first thing we have to consider is whether we are going for a comprehensive application of modular coordination. So if we are going for a comprehensive application of modular coordination, which means that if we are going for an application on the horizontal plane as well as on the vertical plane, the both horizontal controlling dimensions as well as vertical component controlling dimensions are important. So I have explained that the horizontal controlling dimensions are the distances between the distances between the columns or walls, as well as the vertical controlling dimensions are related to the height. So a total standardization of building can also only take place when the modular dimensions are applied horizontally as well as vertically.
So then we have another question. Can you
Yeah.
explain what prefabrication is?
Prefabrication is constructing the building or the making of the building component off-site, which means in the factory. Then transporting it to the site and assembling in the site. So entire process is called prefabrication. So rather than getting all the materials into the site, all the raw materials are arranged in the factory. The components are constructed or made in the factory, and then it is transported to the site and assembled at the site. So the process is known as prefabrication.
Okay, sir. Then there is another question. What is the difference between the modular coordination in of office buildings as well as temple architecture, temple construction?
Temple construction is an example I cited from the traditional architecture of India, but the process is entirely different. The scale used as a module in a temple is not the scale used in the present day architecture. So in the present day architecture, we use the scale of 100 millimeter as the basic module. In the traditional architecture, the scale is different, and the scale you call it a dand. Usually, it is the dimension or the width of the sanctum sanctorum or the prasada. But the basic concept of using modular coordination is the same.
Okay, sir. So these are all the questions that has come in. So if you could discuss the common questions that comes from this portion, maybe it would be helpful for the students.
Yeah. Basically, you can expect some short questions like a definition of modular coordination, then what is meant by a planning module, and you can expect some questions how this modular coordination can be applied to buildings, where the student will have to think and write the answer. Probably you can quote some examples and write the answer. So what is its present day application? Then another question, very important question, is what are the advantages? What are the benefits to construction industry if we go for modular coordination? So I have already explained the benefit to construction industry because mass production becomes an effective method for the construction industry if we go for modular coordination. So due to this mass production, there are several advantages to the stakeholders because there is a reduction in cost, there is a reduction in time. Also, the resources are not wasted because all this mass production process takes place after doing several calculations. So it's a very planned and systematic process. So it is beneficial to the society as well. So these are the basic questions that can be asked for the examination.
Okay, then there is a question from Harita. Can the modular coordination concept be used in interior design?
Yeah, it can be used in interior design as well. But you have to have a pre-planning, especially with the furniture and the components. You have to have a pre-planning. So it can be applied to interior design, especially when we construct all kinds of cabinets, wardrobes, partitions. All is possible, or we can design to the design using modular coordination system.
That's all the questions we have for now.
So we can conclude that. So thank you all participants. Thank you the coordinators of ASAP for inviting me for the session. Thank you all.
Thank you, sir, for sparing your valuable time. Thank you for taking a class for them. And on behalf of ASAP and all the attendees today, thank you very much, sir.